Hi everyone. Today we're going to continue to look at hyperbolas. The last time we talked a lot about hyperbolas, their benefit in life, the uses that we have for them. We explained that things that are specifically made for our eyes, like lenses, contact lenses, television, monitor, binoculars. These things are designed with the mathematical benefits of hyperbola because of the shape of hyperbola. It has a focus. So those materials I just mentioned that are designed for our eyes have used a great use of hyperbolas. But what is a hyperbola? A hyperbola is a set of points xy. This is the graph of a hyperbola. It has these two graphs because this is derived from two cones. So these are two conic sections. This is a mirror of this one. The line in between them, the x-axis, this is the center of the two hyperbolas. So this is at the origin. So then we define what is a hyperbola. A hyperbola is a set of points. Any point here, it has y and x and y coordinates. Any point along this line, it has an x and y coordinates. So a hyperbola is a set of points whose difference of distances, this distance and this distance, their difference from two foci. This is a focus, this is another focus, focus 1, focus 2, is a constant value. That's the definition for hyperbola. In other words, if we subtract D2 from D1, from this point to this point, this is D1 here, from the focus of this hyperbola here to D2 here to this hyperbola, any point here on this hyperbola. If we subtract these two distances, what we get a constant number or constant value. So whether we take from this point here, from this focus here, and draw here another line, we put another line here, that constant value, it will still remain the same. It won't change. But we can put it in a more convenient way. That's why you saw this diagram, you see this diagram below, here. Now, if we are taking the focus, we are taking this line from the focus here to this hyperbola here, you see that this line is longer and this is shorter. So if you are now subtracting D2 from D1, subtracting a bigger number from a smaller number, what do you get? You get a negative number. And we don't want that because we are dealing with lines. We are dealing with distances. You don't expect to get a negative number when you are dealing with distances. So that's why in the definition, this difference we are talking about, the difference of distances from two foci, it should actually be an absolute value. Got to be an absolute value here. We put these two lines. These two lines means if you are subtracting 5 minus 20, what do you get? You know 20 minus 5, you get 15. 5 minus 20, you get minus 15. So if this number, you see this number is absolute value, so minus 15 here now becomes plus 15 because it's a distance. That's what you want. That's why we have these absolute values here. It's very important. That's why I put this diagram below. If you are subtracting a longer distance from a shorter distance, you get a negative number. Because we don't want that, so the formula should actually include an absolute value, the difference of those two distances. Correct. So now I can erase this bottom one after explaining that point. If you want to get the full version of these videos, please follow me on YouTube. My YouTube channel is MUNIRRMKTURAY. This is my YouTube channel. Follow me here, you get the full version of what you see here. Okay? So what we want to do today is to derive the formula of a hyperbola. We all know the formula of a hyperbola is x squared all over a squared minus y squared all over b squared is 1. But how do we get this from here? How do we get this from here? Well, we follow our interpretation of a hyperbola, the definition of given a hyperbola. That's what we follow. We say it's a set of points, xy, whose difference, this distance, and this distance, difference of distances from two foci, from this focus 1, focus 2, is a constant value. This difference of these distances is always a constant value. It's what you get from here to here. That's what they are trying to say. So let's carry on. Now, what is that constant? Let's look for that constant. Here, this is the focus here. This is the vertex of the hyperbola. This is another vertex for this hyperbola here, and this is the focus for this hyperbola here. So if you can just see the coordinates, if we say this is c, 0, this is the center here, this is 0, 0. This is the center, the line that divides the two hyperbolas. It's at the center. If it's at the center, then it's at the point 0, 0. X is 0, Y is 0. That's what it means. So now we say here c, 0. And here is a, 0. That is the value of x. This is the x-axis. The value here for x is a. You see, it's 5. And y, there is no y value here, so it's 0. On this point here, we say the value of x is 10. So we say c. We don't want to put numbers because we are trying to derive a formula. We use letters, which can always be replaced by numbers. Once you have this, the formula like this, we are using letters. So if now they say x is 3, you put 3. If they say a is 2, you put 2. So that's why we are using letters here. We don't want to use numbers. When we come to solving real problems, then we'll be using numbers. But for now, we're using letters. And maybe it's 1 or 2 numbers. So let's see. We want the distance from here to this vertex, from the focus F1 to the vertex V2, because of this line. You see this line? Because we are saying point XY is a set of points. So this point XY along this line. Any point along this line is XY. This curve is XY. So you can see this is minus C, and this is A from 0 here. This point here is A. This is the midpoint line of symmetry. Yeah, this is A. From here to here, for this point here, this is A. And from here to here, this is C. Yeah, it's minus C because it's on the negative side of the graph, but it's actually C. So from here to here you have C. You have C plus A. Okay? You have C plus A. That is from this focus to this vertex, the distance. We are talking about distance. You don't expect negative number. We talk about distance. So it's C plus A. So now we want this distance here from this focus to this same vertex. We want this distance here now. Focus to this vertex. What would that be? You know, from here to this focus is C if you are only looking at the x-axis. And from here to here is A. So what is this one here? This small one here. So this small one going to be C minus A. If from here to here is 10, and from here to here is 5, now what is the value of this point to this point? You just subtract 5 from 10. That is what we have done here. So this is what you've got. So now what is the difference? As our definition tells us, it's a set of points whose difference of distances from two foci is a constant value. How do you make this now? So now, if you say D1 minus D2, this is now equals to C plus A, C plus A minus, because of minus, we put the bracket sign here, C minus A. So what is that? You go C plus A minus C plus A if you clear the bracket sign. When the bracket sign goes away, this A now will be positive. The C will still remain negative. So what do you have? The C's will cancel. C minus C, 0. Now you have A plus A is 2A. So that's what you got, 2A. So now let's find the distances we are talking about. The distance, the absolute distance, FP1 minus FP2. F1, PF1 minus PF2. Okay? That distance, we are told, is equal to this constant value. So what is PF1? Let's start with PF1. This is F1, this is P. This is P here. What is that distance? Let's just say PF1 minus PF2 is now a constant 2A. Okay? So, from your geometry, coordinate geometry, you know how to find the distance of a line. If you are given a line like this is A, B, and you want to find the distance of this line, AB. Find the distance AB. You know, if the coordinates here are x2, y2, and the coordinates here are x1, y1, the x value here is x1, the y value is y1, and the y value, x value is x2, y value is y2. You want to find the distance from here to here, the distance of a line between A and B. This long line cut here, you want to find this distance. Coordinate geometry. So you know, AB squared, this is equals to x2 minus x1 this value here, squared plus y2 minus y1 squared. This is how you find the distance of a line or the length of a line. So you want to find AB. So now this is square. So you can say AB equals to, now the square root of everything, because you want to clear this square, is x2 minus x1 squared plus y2 minus y1 squared. That's what you get, right? When you want to find the distance of a line from coordinate geometry, this is what you get. Because we need it, we're going to use it. That's why I mentioned it. So now let's use it here. PF1. We now see everything is equals to 2a. Yeah? So PF1, we are saying x, we are taking the x minus, you see here, but this is minus again, so minus c squared plus, now y minus 0 squared, because there is 0, this is y, so y minus 0, x minus c, x minus, this is minus c, that's why we have two minuses here, right? That's the distance for this one, for PF1. And then PF2, now this one here, again, you have x minus c squared plus y minus 0 squared. So you got those distances. Yeah? Let me take off this. We don't need it. So we're now saying that, in fact, I should do something like this, square. We're now saying that because we are looking for distances, as we've done previously in this example I just erased from the bottom. So now this is going to be x plus c all squared plus y, now y minus 0 is just y, all squared, square root, as we done previously, minus, now this one, minus again, x minus c squared plus y squared. And we see all this is equals to 2a. This is equals to 2a. Correct? And I use a different ink. My black ink. So what do we do here? All that is left now is just algebra. The moment you reach up to this point here, all that is left is just algebra to arrive at this final stage. X squared over a squared minus y squared over b squared equals to 1. Here we just go to apply algebra here. As we said before in one of the other videos, that algebra is just a relationship. Let's go. So what do we do? This is minus. So I want to bring it over the equality sign so that it will be positive. So now we'll have here x plus c squared plus y squared. Don't forget your square root sign. Now this is equals to 2a minus, now comes over the equality sign, b, plus the square root of x minus c squared plus y squared. That's what you get. Nothing changes, just move one thing from one place to the other and the sign changes. So what do we do according to our study of algebra? If we square both sides, because this has got a square root sign, we want to remove the square root sign. This is what we got to be doing now, trying to eliminate the square root sign. You can't work with it, with the square root sign. It's difficult. You always try to get rid of it. That's why you do sorts. You do conjugation of sorts. They come with square root sign. Try to eliminate the square root sign. So, what do we do? If we square this, because the square root of the square of a number is the number itself. The square root of the square of a number is the number itself. If you are given 25, the square root of 25, this is 25 square roots. If you square it, you still get your 25, because the square root of 25 is 5. That the square root is gone. If you now square it, what do you get? You still get 25. That's why they say the square root of the square of a number is the number itself. So what we do here, we square this, and we should also square this one. What you do on the left hand side, you must also do on the right hand side, because we got an equality sign here. So if you square this, just the square root will go away. You will still have your x plus c all squared plus y squared. The square root will go away. But here, it won't go away. Here you got to do a lot of things here now. So you square, you're having 2a plus the root of all what is inside times 2a plus the square root of all what is inside. This is what we are doing here. So, again, there is a formula. If you have a plus b squared, you want to square these two, it's always a squared plus twice their products. Twice plus twice their product. Product of a and b is ab. So twice is 2ab plus 2ab, then plus b squared now. So you have a squared, b squared, then plus twice their products. This is the formula. So we'll do it here. So we have this one, which is 4a squared, plus twice their product. Already you have 2 here, times 2, so you get 4a, the square root of x minus c squared plus y squared. Then you now have b squared, which is d squared. Again, when you square this, just the square root will go away. So you have plus x minus c all squared plus y squared. This is what you get. And since this is an equation now, you have an equality sign, you keep on eliminating what you think it should be eliminated. From here, straight away, you will see there is plus y squared plus y squared. Let us just get rid of it. If we take one of this y squared, you move it next to the other one, the sign will change and it will cancel. If you bring this one here plus, it comes out to be minus y squared. So y squared minus y squared will go. So when you see something like this, just cancel it and forget about it for now, so that you reduce your work. So we're going to expand this. This is x plus c squared, and here x minus c squared. They are not the same. This is minus, this is plus here. If again what we did here, we'll do it here. You get x squared plus 2cx plus c squared, expanded this one, equals 4a squared plus 4a, this we can't do anything, c minus x minus c squared plus y squared plus, again, we expand this one. You get x squared minus 2cx plus c squared. When you expand this one, this is what you get. You get this equation. And here, what can we see again? We see that there is a c squared here, there is a c squared here, there is an x squared here, x squared here. So we get rid of them because there is an equality sign here that allows us to do it. So this goes, this goes, this goes, this goes as well. So what is left here is just 2cx. And we have minus 2cx. Why can't we bring them together? 2cx, they can't cancel because this is minus, this is plus. So we bring one next to the other. So we take this negative one and bring it over there. So minus 2cx minus plus 2cx. So when it comes here, it's going to be plus. So plus 2cx plus 2cx going to be now 4cx equals 4a squared plus 4a, then the square root of x minus c squared plus y squared. We're here so far. So again, can you spot anything? Yes. We have the 4s. The 4s can cancel. We have 4 here, 4 here, 4 here. You can take rid of them. So this 4, divide throughout by 4. 4 goes. I'm sorry, I got to erase some aspects so that I'll have more space. I hope we are correct up to this point. So you now have c x equals a squared plus, I'm just copying this one, a, the root of x minus c squared, x minus c all squared plus y squared. Mind you, we are trying to derive this formula. This is what we are heading to. So now, after writing all this, I can erase all this one here. Everything. I got it now here. So what do we do? What do we do? Now, again, we've got a square root sign here. We want to get rid of this square root sign. So I want to take this a and bring it over here. So this is going to be cx minus a squared equals a, the root of, square root of x minus c all squared plus y squared. So in order for us to get rid of the square root sign, again, we multiply everything by, we raise everything to the power of 2 to get rid of this square root. So now, if we square this, we also square this. It doesn't change the equation because we have an equality sign here. But if you expand this now, this is going to be c squared x squared minus 2 times their product 2a squared c x plus a raised to the power of 4. Now, this is a raised to the 2, square it, get a raised to the power of 4. And this is equals to now, this will be a squared, square this, because the square root sign doesn't reach here. So all this now will remain x minus c, yes, squared plus y squared. This is what you get. X minus c squared plus y squared. This a is affecting all of them, so I should actually put this because a is multiplying everything inside. Correct? So this is c squared x squared minus 2a squared cx plus a raised to the power of 4 equals a raised to the power of 2 into, now let's expand this. Expand this one here, you get x squared minus 2cx plus c squared plus y squared. And now I want to expand again, multiply throughout my a. So now you get here c squared x squared minus 2a squared cx plus a raised to the power of 4 equals a raised to the power of 2x squared. I'm distributing this a to everything here. Minus 2a squared cx plus a squared c squared, a squared c squared plus a squared y squared, a squared y squared. So what else can we do here? You have the x's. Have the x's. So yeah, you look at it and you see what you can do to ease the problem, to make it look simpler. So now we got to bring like terms in one place, or collecting like terms together. So what do we do here? I want to bring, this is 2a c. Oh, you have minus 2a squared cx minus 2a squared cx. So this can cancel because this is minus here. This again is minus here after the equality sign. So this goes with this. Yeah? So now you are now left with c squared x squared plus a raised to the power of 4 equals to a squared x squared plus a squared c squared plus a squared y squared. This is what is left. Yeah? So let me bring now things, try to bring things in one place. This is a squared. Yeah? I want to bring this one here on this left hand side and I leave this on the right hand side. In other words, if I say a squared x squared plus a squared c squared, a squared c squared plus a squared y squared is equals to c squared x squared plus a to the power of 4. It's the same equation. No sign changes. I just want to bring one on the left hand side and the other one on the right hand side. Because what I'm trying to do, I need this a, I need x upon a and y upon b squared. Oh. Does that work? Let's see. Should be getting minus. No. Let's see. I know if I have trouble, we'll come back here. So now, if this is a squared, c squared, yeah? Now I should even bring this x here. Now let's see. Anyway, we have a squared x squared Let us leave this as it is. Let us leave this as it is. So now here you have c squared x squared. I'm bringing this one here again, minus a squared x squared over the equality sign, minus a squared y squared, this goes over the equality sign, is equals to a squared c squared minus a raised to the power of 4. Can you see this? C squared x squared. I'm bringing this, and I'm bringing this as well. And then I'm just bringing this over the equality sign. So what do we have? Here, you can see that there is x squared is common here. So you have x squared into c squared minus a squared, because x squared is common. Yeah, so I'm factorizing here. And here you have minus a squared y squared equals, here again you see the a is common. You have a raised to the power of 2 and a raised to the power of 4. So I can say a raised to the power of 2 all over c squared minus a raised to the power of 2. This instead of 4 now is 2, because if I clear the brackets, sign it will be a to the power of 2 times a to the power a raised to the power of 4. Correct. We're almost there. So here, you can see when we are doing this derivation of this formula here, there was no b. No b is mentioned here. There is no b. Can you see b here? No. But how come there is b in the equation? This is where b comes in. When you start to solve problems, actual problems, you will see where the b is coming from. This vertex here, it falls along the transverse line. This is the line that transverses the two hyperbolas. There is also a co-vertex that will appear on the other side of the axis. This x-axis. There is another co-vertex on the y-axis. But when you start doing actual problems, you will see that. You will see it clearly. So for now, since we have c squared minus a squared and c squared minus a squared here, what if we say c squared minus a squared is equals to b squared? C squared minus a squared equals to b squared. What if we say so? We now have here x squared b squared minus a squared y squared equals a squared b squared. If we say let c squared minus a squared equals to b squared, later on you start to solve problems, you will know why. Yeah, we just represent, it's a constant. C squared, a squared, these are constants, so we can represent this by any constant. So we say b squared. That's what we have done. So what is now left? If we divide throughout this equation by a squared b squared, if you divide this by a squared b squared, you also divide this by a squared b squared, you must also divide this by a squared b squared. And then you do your cancellation. If you do your cancellation, you can see that b squared cancels b squared. And here a squared cancels a squared. And here a squared, b squared, a squared, b squared, they cancel each other. So what is left here is 1. And now here you have x squared over a squared minus y squared over b squared equals 1. Hence we prove this, we arrive at this result. The results we are looking at, we arrive at it here. I hope you enjoyed this lesson. As I mentioned earlier, if you want to get the full version of this recording, you follow me on YouTube. My YouTube channel is Munir MK Toure. Thank you for watching. Bye bye.